So TensorFlow. So what is TensorFlow? It's an open source machine learning or deep learning. It's an open source machine learning or deep learning library or platform. It's an open source machine learning and a deep learning library or platform. So this TensorFlow was developed by Google Brain team. So the meaning of open source is it's freely available. You can use it, you can just install it and use it freely. You need not pay if you are using TensorFlow. So this is library means it contains a lot of functions, a lot of useful machine learning, deep learning and other numerical computation functions. You need not write code for those functions. You can directly use those functions, just give a call to those functions, right? So for example, if I want to create an array, I can give a call to a function by using tf. Tf stands for TensorFlow dot, let's say, constant. If I want to use, so this is a function with, I'm giving a call to this function just to create, let's say, this array. We'll see later what are these arrays and all that. So this is from TensorFlow. I'm giving just a call to this constant function which will create this array, numerical array for me, right? So how I came to know it's a function because of these two brackets. We are giving call to the function. Right? So the code for this constant is already written in the TensorFlow library. I need not tell the computer what is this constant and how to create this array, the entire procedure. Like there is a lot of code behind this. So I need not write all of that code. I'm just giving call to this constant and I'm able to create. So this will create an array of array 1 to this array it will create. Array of 2, array of constants it will create, right? So this TensorFlow contains many such functions. You can use those to develop your machine learning or deep learning models and train those models and get end results for solving many complex problems. May it be a research problem, may it be a real life problem. So now let's see why it is a tens. What is the meaning of tensor, right? The main word here is tensor. What do you mean by tensor, right? So basically, tensor means an n-dimensional array. N-dimensional array. Arrays, right? So, for example, so if I write this, this is called as scalar because it's a single number. It's a single number. It has zero dimensions. It has zero dimensions. That's why it's called as scalar. It has zero dimensions, right? So it's a single number is always called as a scalar or zero dimensional array. Now if I have, let's say, this array, so this is one dimensional array because it contains only one row. It contains only row, no columns, right? So that's why it is one dimensional array. Now if if an array contains rows and columns like a matrix, if an array contains rows and columns like a matrix, for example, if I have this 1 comma 2, this is one row, and if I have another row here, so this is called as a two-dimensional array because it contains two rows and two columns. It contains rows as well as columns. So this is the first row, this is the first row, this is the second row, this is the first column, second column. So that's why it has rows and columns. There are two rows and two columns. So that's why its dimensions are 2 by 2. It's 2D array with these dimensions, two rows and two columns. If I have a matrix like this, 1 comma 2 comma 3, 4 comma 5 comma 6, it contains two rows. This is the first row, this is the second row, and three columns, first column, second column, and third column. So that's why its dimensions are 2 by 3, two rows and three columns. Now internally, if we see the representation of these arrays in the computer memory, right? If I represent this array in computer memory, it is represented like There are no rows and columns in computer memory, so these numbers are stored sequentially. For example, so if so this 1 2 is written like this. If I represent it, if I show it flat representation, so this is the first row. First row goes here, and the second row immediately goes after this comma 3 comma 4, right? So these numbers are sequentially represented in memory. 1 2 3, they are stored sequentially in memory. There are no rows and columns. We need to differentiate ourselves up to what is the first row and where the second row starts, right? So now that is how I can create my 2D array, right? So this is 2D array. So this is 2D array because it contains 2D array contains why I am calling it as two-dimensional array, because two-dimensional array contains the one-dimensional arrays as element. This is first one-dimensional array element of this 2D array is the one-dimensional array, first one-dimensional array. This is the second one-dimensional array, right? So this is first one-dimensional array. This is second one-dimensional array. So 2D array contains one-dimensional arrays as elements, right? So by the way, this is called as 0th position in an array, and this is called as first position, right? Now if I go to this array, this is called as 0th location in the array, first location in the array, right? So in case of 2D array, so this is the first element of 2D array, and this is the second element of 2D array. So first location is called as 0th location, and second location is called as location number 1, right? So inside this 2D array, I have two elements. This is the first element, this is the second element. Now this first element itself is one-dimensional array. This first element or 0th element itself is one-dimensional, one-dimensional array, right? So this contains this is 0 location. Now if I show this is 0 location inside this one-dimensional array. This is location number 1 inside this one-dimensional array. Now this is location number 0 inside this one-dimensional array. This is location number 1 inside this one-dimensional array, right? So now if I want to reach to this element, how can I let's say name of this array is A, right? So I can go to this location by saying A of, right, A in the bigger array or bigger two-dimensional array. I want to go to 0th location or 0th element, right? Inside this 0th element, I want to go to 0th element, that is this. That's how I can refer to this, right? A of 0 0. A of 0 0 means inside the 0th location or 0th element, I'm going to the 0th element, right? And inside 0th element, again I want to go to 0th element, right? That is this location. Now if I want to go to this, let's say this one, so how will I go there? A, name of the array. Inside A, I want to go to first element number 1, and inside element number 1, I want to go to again element number 1, A of 1 1. So that is how I can go to this element, right? Okay, so now this is a two-dimensional array of, that means two-dimensional array contains elements which are one-dimensional array themselves, right? So, and one-dimensional array contains elements which are scalar themselves. For example, this one-dimensional array contains this element which is a scalar like this. So this is a scalar like this, right? Okay, so now let's move on and see how can I have three-dimensional arrays, right? Now we saw that I have two-dimensional arrays which contains, let's say, one-dimensional array as element 1 2 1 2 and 3 4, right? So this is it. This A is a two-dimensional array, right, which contains these two elements which are one-dimensional array themselves, element number 0 and element number 1. So now if I want to create a three-dimensional array, so three-dimensional array contains two-dimensional array as elements. So let's say B is equal to, this is a three-dimensional array, let's say. So what it will contain? It will contain two-dimensional arrays as elements. So this is, let's say, first two-dimensional array, and this is second two-dimensional array, right? So here I can write this as it is because it's a two-dimensional array. So this I'm writing as it is 1 2 3 4. So it's a two-dimensional array, right, which is element of this three-dimensional array, right? And the second, I'll write the second element here. The second element of this 3D array, let's say 5, 6, and 7, 8. So this is second two-dimensional array element, right? Second two-dimensional array element. This is the zeroth location inside this three-dimensional array. This is location number 1 inside this three-dimensional array. Now inside the zeroth location itself is a two-dimensional array. So this is zeroth location inside this. So just a moment. So inside this 2D array, this is a zeroth location, and this is location number 1. Inside this two-dimensional array, this is zeroth location, and this is location number 1. Now inside this zeroth element, the zeroth array, zeroth element itself is a one-dimensional array. So inside this one-dimensional array, this is zeroth location, and this is location number 1. So if I want to reach to this element, let's say, right, how will I go there? B of inside B. First, you need to go to 3D element, that is 0. That you want to go to this zeroth element. Inside 0, which two-dimensional array you want to go? This one, right? This which one-dimensional array you want to go? This one, right? Right. Inside this 2D array, which is zeroth location, that is this one. Inside this 2D array, which is zeroth array, you want to go to zeroth 1D array, zeroth. And inside this zeroth 1D array, which location you want to go? This zeroth location. That's how you can reach there. If I want to reach to, let's say, this location, right? What is this? This is element number 1 inside the 3D array, and this is element number 0 inside this 2D array, and inside this this is 1D array, and then there this is element number 1. This is 0, 1. This is 0, 1. So if you want to go there, so I will say B of, first you will go there in 1. Inside 1, you will go to this zeroth element, right? And zeroth element contains this one sub-element, right? So that is how you can go there, 1, 0, 1. Right? Now the idea is the 2D array contains 1D arrays, 3D array contains 2D arrays as elements, and 4D array contains 3D arrays as elements, right? So you can go on nesting, you know, as many dimensions as you want. So we'll build these arrays, and these, you know, multi-dimensional arrays, they are called as tensors. They are called as tensors. So this is a tensor, right? So the tensor is nothing but a multi-dimensional array. So we'll see how to build this multi-dimensional array by using Python, all right? So we are going to use Google Colab for writing all of our code. So we'll see how to write this, how to create these arrays in Google Colab.